So once you are given a data set or once you are given a problem, you need to identify whether this function is the correct one or you need to pick a new loose function for this problem. And then we choose optimizer. So here, you need to understand that we need to pick an optimizer to do the back propagation optimization to optimize all the parameters. But you do not need to differentiate all of these optimizers here. Okay? You just need to know that we need to pick one optimizer for optimization process. So also to prevent the overfitting of the artificial network, we need to have certain steps. For example, regularization and dropout. So how the regularization and dropout can help us prevent overfitting or to prevent a very complicated neural network. So to implement this one, so we learn in our tutorial how we go from the preparation, define model, choose the loop function, choose an optimizer, and train the model. So in week 3, we learned the time series analysis. So basically, you need to understand the main difference between the sequential model. We do not have to video technique because I did not have my formal yet. I forgot one. Okay. So I will post this slide online. I don't have video technique, and I don't want me to go public today. Okay. So you need to understand the main difference between the artificial network and the recurrent loop. So what is the key modification of the neural network structure that enable the memory mechanism in the recurrent neural network? So if you unfold, we learn that we apply a hidden state to remember some of the information we get from the previous timestamp. So you need to understand how this hidden state works in the recurrent loop. So this is a key difference, and you need to explain how it works. And then, if you understand that as a network structure, then every step will be the same as what we learned before in the artificial network. This thing, the gradient is same. Now, for the recurrent network, you need to understand that there is a big issue in the back propagation, and this is a problem, the gradient problem in RNN. And what is the issue of this problem in gradient descent, and how we need to modify this model structure to prevent this kind of issue. And so the solution becomes the LSTM. So you understand how the LSTM can help solve this problem. And the main difference between RNN and LSTM and how the LSTM is working. So in LSTM we have 3 different modules, and how these modules work together to enable the long-term memory and short-term memory. You understand this? So all together, how all these modules work together to update the self state, and self state will remember the short-term and long-term information. And finally, because the LSTM is too complicated, we learn a very brief introduction of the GRU, the gauge recurrent unit. The actual fit is between the LSTM and the RNN. So it is simplify the LSTM model, but still it can remember part of the long-term memory. So usually tell the differences among these 3 sequential models, and how the GRU works better among the 3 sequential models. And then we learn how to model the language as a sequential data. So you understand that the key information we need to get from this learning framework is to learn the vector representation of different keywords in your document. So we learned how to do vectorization. You need to understand different vectorization methods. So especially how we actually do the preprocessing for the vectorization, and then we learn how to do this kind of one-hot encoding to vectorize the text using the dummy vector. And we know that this is working very well in some of the problems. And then we learn how to use the TF-IDF to vectorize the document using the TF and IDF. So how the TF and IDF work together to vectorize the document data. And we also know that this the disadvantages of this kind of TF-IDF. So we go further into the language model. And the basic understanding of the language model is to find the vector representation of different keywords, and this vectorization, the vector of different keywords can show the contextual relationship among different keywords. So to do that, you need to understand how the neural network language model actually constructs